Welcome back. We're on section 4.3. It was exactly this section that prompted me to return to making these videos because a student, Mr. Mers, wanted to know what does all this mean without the gobbledygook. So let's see if we can kind of take this apart and see what they're talking about. Given the graph of this function, use a left Riemann sum with 4 rectangles to approximate the integral from 2 to 4 of f of x. So I have here my function f of x. And here, let me get a picture of it so that way I can kind of write on it. Click this button, and then I will click this button, and then okay, here's a picture of it for me to write on. Now they want a left Riemann sum with 4 rectangles, and this is my function f of x. That's what's represented by the curve. So that's my function, and if I integrate from 2 to 4, so the integral from 2 to 4 is exactly this area, right? Whatever this area is the integral from 2 to 4. I can approximate that area with rectangles. Rectangles are easy to calculate the area of. So let's draw some rectangles. All right, there's a rectangle. We know the height of that rectangle. We know the width of that rectangle. Here's another one, and this is a left Riemann sum, so that means the left corner points of my rectangles are what touch the curve. The top left corner, because it's a left Riemann sum. Here's my 3rd rectangle, and here's my 4th rectangle. And now I've got 4 rectangles that approximate that area. So that area is approximately, what am I trying to approximate? I'm trying to approximate the integral from 2 to 4 of f of x. It is approximately the height of the first rectangle. What is the height of the first rectangle? Yeah, you can see that this is 5, right? You can see that it's 5. And the width of that rectangle is just 1/2. That's my first rectangle. My second rectangle has a height of 3 and a width of 1/2, and the third rectangle has a height of 2 and a width of 1/2, and the fourth rectangle has a height of 4 and a width of 1/2. But they all have the same width of 1/2, so that can be factored out. And in fact, each of those numbers, 5, 3, 2, and 4, 5 is really just f of 2. And 3, that's f of 2.5. And then the 2 is f of 3. And the 4 is f of 3.5. So this will deliver to me my numerical answer. But having this perspective, very handy. It's a left Riemann sum, so we just started with the leftmost endpoint and scooted over each time in our x coordinate by the width of the rectangle. Which is why sometimes this 1/2 would be replaced with what was our change in x? What was our delta x? How much did we change? So what is my numerical approximation? It's 14 over 2, so set. All right. Given the graph, use a right Riemann sum with 4 rectangles to approximate this interval. Okay, let me get a picture of it. Picture, let me make it bigger. So what we have, so that curve is your function. That curve is f of x. And they want me to approximate the integral from 2 to 6 scoot this over a little. So they're wanting me to approximate this area. The area enclosed right here. This is what I'm supposed to approximate. All of this area. Let me approximate it with rectangles, in particular a right Riemann sum of 4 rectangles. So this would be the base of the first one, and this would be the base of the second one, and this is the base of the third rectangle, and this is the base of the fourth rectangle. You can see that they wanted us to approximate the integral from 2 to 6 of this function. They wanted me to do it with 4 rectangles. So my delta x has got to be, it's just how far are you having to integrate divided by how many rectangles you want to break it up into. So I know that the width of my rectangles is always just 1. That's how much I'm going to change my x value, by 1. and it's a right Riemann sum. So the right corners of the rectangles are what's going to touch the curve. So there's my first one, and then here's my second one. Third rectangle is there, and the fourth one is here. That's a right Riemann sum of 4 rectangles. And without even looking at the drawing, then we would know that, you know, so the first rectangle does not have a height of f of 2. It has a height of f of 2 plus delta x. So its height is f of 3. Right here at 3, the height of that rectangle, it goes up and touches the curve there. So its height is just f of 3. So delta x is 1, and my first rectangle has a height of f of 3, and my change in x is 1, so this should be f of 3 plus 1, and then f of 4 plus 1, and then f of 5 plus 1. That's 4 rectangles. I'm done. That's my right Riemann sum. Riemann after the mathematician Bernard Riemann. So really it's just f of 3 plus f of 4 plus f of 5 plus f of 6. Well, f of 3 is 2, and f of 4 is 3, and f of 5 is 6, and f of 6 is 9. And we're done. This adds up to 20. Oh boy, another graph. Okay. Let me get a picture of it. There's my function. And what did they want from me? A left Riemann sum with 4 rectangles. Here they want a left Riemann sum with 4 rectangles that approximates the integral from 3 to 5 of this function. You can almost see graphically here that since I'm just going from 3 to 5, and you've got to break that up into 4 rectangles, then it must be the case that each rectangle only has a width of 1/2. So my change in x is the length of my interval divided by how many pieces I'm going to break it up into. That's 2 over 4, that's 1/2. It's a left Riemann sum, so my left endpoints are what's going to touch the curve. This is what the rectangles look like. You can see my 4 rectangles. It's their top left corners on the curve. This is a left Riemann sum of 4 rectangles. So that area is equal to 1/2 times f of 3 plus f of 3.5 plus f of 4 plus f of 4.5. We didn't get to f of 5. You'll never get to f of 5 on a left Riemann sum because you only have 4 rectangles. So I've seen this I've seen this denoted like L4. It's a left Riemann sum of 4 rectangles. R4, on the other hand, the right Riemann sum of 4 rectangles, would not start with f of 3. It would start with f of 3.5 plus f of 4 plus f of 4.5, and then you get plus f of 5 to get that 4th rectangle. That would be the right Riemann sum. But here it's just going to be, here we're not doing this one, it's just the left Riemann sum. And numerically, that's going to be, well, all of the rectangles have a width of 1/2, and the height of the first one is 5, and the height of the second one is 3, and the height of the third one is 2, and the height of the fourth one is 4. And so that's 8 and 6. 14 over 2, we get 7. So this is approximately 7. Awesome. Okay, more of the same. Except now it's 6 rectangles on the interval from 1 to 4. Okay. See if I can include those instructions this time. They want a right Riemann sum of 6 rectangles. Okay. They want it to approximate the integral from 1 to 4. So we're going to be going along this path. It's a right Riemann sum of 6 rectangles. So my first one is right there, second one is right there. And here's my third rectangle. And there's my fourth one. And there's my fifth one. And there's my sixth one. And these 6 rectangles approximate that interval. All their widths are 1/2. The height of the first one is 5, and the height of the next one is 3, and then 3, and then 5, and 5, and 5. So that's 26 over 2, you get 13. Cool. Okay. Now they want me to do this one with 4 rectangles on the interval from 2 to 6. Part of that curve dips below the x-axis. So we're going to be taking away some area from the rectangles that stick up above the x-axis. Because it's the idea of how it's rectangles, areas of rectangles, and we just add up all the areas, really only matches when the curve is completely above the x-axis. Strictly speaking, the Riemann sum should be the sum of the functional values. Here, let me show you what I mean. So, let me get a picture of it. Okay. Then the width of my rectangles is equal to the length of that interval divided by the number of rectangles they want. So my delta x is 1, and it's a left Riemann sum of 4 rectangles. So it's going to be delta x times the sum of f of, and it's a left Riemann sum, so I can start right at 2, but I won't go to 6, it'll only go to 5. F of 2 plus f of 3 plus f of 4 plus f of 5. And that makes 4 rectangles. Delta x is just 1, and f of 2 I can see is 6. F of 3 I can see is 5. So here's f of 2. F of 3 I can see is 5. F of 4 is 2. And f of 5 is minus 1. So that's my Riemann sum. And you get 12. mastery. I guess they're all going to be pictures, huh? Do a left Riemann sum of 4 rectangles. Oh, you can't see what I'm looking at. Or can you? Yeah, you can. Do a left Riemann sum of 4 rectangles. Let's get a picture. Click that, click here. Is all right. It's an approximation with 4 rectangles, and the length of my interval is also 4, so delta x is 1 again. But that left Riemann sum of 4 rectangles is just, it's nothing more than delta x times, there's my delta x, times, and since it's a left Riemann sum, start with the leftmost endpoint of that path that you're integrating over. So you're going to have f of 1 plus f of 2. It's f of 2 because it's f of 1 plus delta x. Delta x is 1 plus f of 3 plus f of 4. There, I have 4 rectangles now. And f of 1 is just 7, and f of 2 is 5, and f of 3 is 4, and f of 4 is 0. And so the left Riemann sum of 4 rectangles is 16. Alright, 1 of 2 objectives completed. Does that mean they're going to ask me a different type of question? Of course not. 3 rectangles to approximate this. Okay, well, 6 minus 3 is 3, and 3 over 3 is 1, so my delta x is 1. My delta x is 1. Let's just back up for a second. Then this is the integral from 3 to 6 of f of x. I'm going to approximate it by a right Riemann sum of 3 rectangles. But that right Riemann sum of 3 rectangles is just nothing more than delta x, which in this case is 6 minus 3 over 3, there's my delta x, times, now I can't start at f of 3, because 3 is the lefternmost endpoint. Right? We would have to start at f of the quantity 3 plus delta x. That way it stops at the rightmost endpoint of our path. So that right Riemann sum is just the addition of these 3 numbers. F of 4 plus f of 5 plus f of 6. Well, f of 4 is 7. 7 plus 9 plus 11. That's what they want. So it's 27. 6 minus 2 is 4. Divided by 4 is 1. Delta x here is 1. It's a right Riemann sum, so I'm going to be ending with f of 6. If you'd like, you could say f of 6 plus f of 5 plus f of 4 plus f of 3. Once you hit a sum of 4 things, you are done. So it's f of 6, which is 8, plus f of 5, which is 9, plus f of 4, which is 7, plus f of 3, which is 4. And f of 6 is 8, and f of 5 is 9, and f of 4 is 7, and f of 3 is 4. So it's 8 plus 9 plus 7 plus 4, you get 22. Wait a second. That's 11. That's 20. I get 28, not 22. 28. All right. And that's it. Awesome. All right. See you in the next one.